In this video, I'm going to show you how to do AQA A-Level Maths, June 2018, Paper 1, Question 12. My name is Sunil Tanna, details on the card. I'm an author and tutor. I'm available for one-to-one tuition, online and in person. I live in Buckinghamshire, England. Question 12. P of x is equal to 30x cubed minus 7x squared minus 7x plus 2. Prove that 2x plus 1 is a factor of p of x. So there's two ways really to go about this. One would be to do polynomial long division by dividing by 2x plus 1 and showing that there's no remainder. The other is to use the factor theorem. Now the next part of the question actually does require polynomial long division, so that would probably be the easiest way to do it to save time. But so for completeness, I'll show you how to do this using the factor theorem. So if 2x plus 1 is a factor, this would mean that minus a half is a root. Because 2 times minus a half plus 1 is equal to 0. And so what we can do is use the factor theorem. I'm going to write here factor theorem. We're going to calculate p of minus a half. So in this case it will be 30 times minus a half cubed minus 7 times minus a half squared minus 7 times minus a half plus 2. We can calculate that, it comes out to 0. So this shows you as p minus a half equals 0, 2x plus 1 is a factor because of the factor theorem. Now we need to factorize completely, so at this stage we have to do either polynomial long division, or we could factorize by inspection. But let's do the polynomial long division. You could have, of course, done this as an alternative for part A of the question. So what we're going to do is we're going to divide 30x cubed minus 7x squared minus 7x plus 2 by 2x plus 1. So what you do is look at the 2x and say, what do I need to multiply it by to get 30x cubed? I'd need to multiply it by 15x squared. So 15x squared goes here. If I do 15x squared times 2x plus 1, that will give me 30x cubed plus 15x squared. And now I subtract. So minus 7x squared minus 15x squared is minus 22x squared. I can bring the other terms down, minus 7x plus 2. So what do I need to multiply 2x by to get minus 22x squared? So I need to multiply it by minus 11x, so minus 11x goes here. Multiply this by minus 11x gives minus 22x squared minus 11x, and again we subtract. Minus 22x squared minus 22x minus 22x squared is of course nothing. Minus 7x minus 11x will give us plus 4x, and then bring the 2 down. What do I need to multiply the 2x plus 1 by to get 4x plus 2? By 2. So it goes in 2 more times, and then that gives me 4x plus 2, and you can see there is no remainder. So now that we know that this function factorizes to p of x is equal to 2x plus 1 times 15x squared minus 11x plus 2. Now, we now need to factorize the quadratic part of that equation. You might be thinking the 15x squared, it could be 15x something and x, or it could be 5x and 3x in the two brackets. Now, if you look at the plus sign on the end, this tells you both of the factorized brackets will be minus signs because you need a minus term in the middle. You need two numbers that multiply to 2 and 1, and then when multiplied by the other term will give minus 11. If you try a few combinations, you'll find that neither of these never works with this, but you can do 2 times 3 is minus 6, and 1 times 5 gives you a minus 5, so minus 11 overall. So this factorizes to 2x plus 1 times 5x minus 2, 3x minus 1. Okay, I'll cross that part out. Okay, so now we have our part B of the question. There's now part C of the question, which initially looks somewhat different. It says, prove that there are no real solutions to the equation. Now, if you look at it, the equation includes both sec and cos terms, and of course we know that sec of x is the same as 1 over cos of x, so cos of x would be the same as 1 over sec of x. So what we can do is rewrite this formula in terms of sec x. So it would now become 30 sec squared x plus 2 times 1 over sec x all over 7 is equal to sec x plus 1. Now, multiplying both sides by 7 gives us 30 sec squared x plus 2 over sec x is equal to 7 sec x plus 7. Now, if we multiply everything by sec to get rid of this divide by sec x, we will now get 30 sec cubed x plus 2 is equal to 7 sec squared x plus 7 sec x. And if we bring it to one side, we'll end up with 30 sec cubed x minus 7 sec squared x minus 7 sec x plus 2 equals 0. Now, if you compare this to p of x, which we had in part A and B of the question, it's exactly the same formula, except for instead of x, we have sec x in each case. So we can use the same factorisation. So this factorises to 2 sec x plus 1 times 5 sec x minus 2 and 3 sec x minus 1 equals 0, which gives us the following values of secs as root of this equation. So sec x is equal to minus a half from the first bracket, or sec x is equal to 2/5 from the second bracket, or sec x is equal to 1/3. Now, if you think about what we said earlier, sec x is 1 over cos x. You know that cos varies between minus 1 and plus 1. So if you think about that, this number, if it's a negative on the bottom, sec will always be smaller than minus 1 or equal to minus 1, or sec x will always be bigger than 1. The range of sec x is either, range of sec x is either less than or equal to minus 1, or sec x is greater than or equal to 1, which means none of these actual solutions are valid, real solutions to the original equation. So, no valid real solutions. And that's the end of the question.